So, hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 46, and in this video we learn a new keyword, which is the double primitive. So, but before we go on, let me show you fast how we can change a switch statement, which we learned in the last video, into a if statement, because I said they are similar, very similar. So here what you see is an example, and you see how I wrote all time the break statement after each case, which means if you find this one, you should stop here. But if you don't write here a break and it finds, for example, and it's the case 1, it would go to the next statement till it finds a break. Don't forget this one, but let's try to convert this one to an if statement. So what we do is we start again if, then we write here the condition like here, but here we can't use this condition variable, variable. Perhaps I should change here the name a little bit. So what we have to do is we use this with a comparison. We just compare this variable, and to what we are going to compare it to the cases, because this case here is the value which is expecting. So I can just write here condition variable is equal, and then I just watch here case 1 is 1. It should be 1, right? And then I write here my opening, then I will write here my text and copy this one here, and then I would go to the next case, and there I just write else if, else if, and here I write again this condition. I copy this one, it's a little bit faster. So, and then I show what the case here is. So the second case is, in this case it's 2. Of course it must be not 2. You can choose here whatever you want, depends on this condition variable, right? But this was a simple example only. Let's continue a little bit, and I'm almost finished, and then I copy this one again. Yeah, then I do this one here, copy it in it, and I'm almost finished. And because I'm a little bit lazy, I copy this one. But before I copy this break, careful, if got not a break, this break is only needed for our switch statement. Save this one, copy this one, and do this for all cases. Let's say if I have more cases here, I would go on with this else if, else if, else if, till I found the default one. And in my case, I found it after the case 3, and there I just write it an else. And actually, that's it. And then I copy this statement there, copy this one, and change a little bit the text, of course. All time when you copy, make not the mistake which I did here, not to change the text here, because that's very important that you change whole time the necessary code after copying. But with that said, this is already our solution. So you see, let's comment this out. Careful, not comment out your condition variable, but this one we still need. Control C for commenting, and now we can test. Let's start, and we see this is case 3. So let's see, it says this is case 3. So we should have here the number 3. Yes, we have, and number 3 is doing. So you see, converting this one to an if statement is easy, and the special case where it should run the other ones is easy possible too. But we go on now with our double. So I said we learn a new data type, and the new data type is double. What is a double? Actually, it is just a number again, and even more, it is similar to one number which we know. It is just a float. Let's say not a float, it is similar to a float. That's more correct. And I'm just commenting this fast out here, so that that it's not gone, that I can use it later. So let's introduce the double. And I said double is a primitive type, which means I write just double. So when I write it right, double, and it is just a number. So it is similar to float, but it is not a float. That's very important. And this is a declaration, but I want also assign a value to it. And how I assign a value to it, I just write 1 point anything here. And then I make this. And then I print this out, std out. And what we have here, we use, of course, the variable name again. Is similar to float, but it is not a float. And when I print this out, what we get is here an output, and it cuts 1, 2, 3, 5, 6. After the 6th one, it cuts off because this is the default setting for Visual Studio, I think, for precision. We can set this later more if we want, but in general, it will cut off about 6 digits. So, okay, it is just, when we watch this now, it looks really similar to a float. Let's repeat what a float is. I write float here and say this is a float. And make here, the difference here is about behind a float, I have to write this F to indicate that this one is a float, right? And now I have, when I compare these two numbers, they look similar, they actually behave similar, and they are similar. The only difference is here, this double has more precision. And to explain here, precision is a little bit hard because we are interested only in practical use in this tutorial. So you need, again, an online documentation or a good C++ book where the precision is explained. But what does mean this precision? I want to show you here on the web. For example, you can go here and say what I typed here, C++ difference, float and double, and then I watch most time in Stack Overflow. And why I'm going to Stack Overflow? Because it's a very nice site where many questions are asked, and then you can click it. And very important, they are not all time 100% right, because these are most time normal people. What I mean with normal people is they are not here to give an absolute accurate correct answer. So they are just giving a normal correct answer which a human can understand. And I say this all time in comparison to the theoretical formal answer. For example, when you watch the formal definition of a double and go to the papers of C++, how they define their double, this would be more correct and more precise, but it's harder to understand and probably not so, you would not understand it so fast. So let's go into it, and you see what they say. There are different kind of answers. You see every person answer here something, and on top here you find probably the which are with the most voted answers. This is a good one. You can see 609 voted this were good, but means still not this this is absolute perfect, but it's a good answer to understand it. And here you can see also the difference about a double is here, as the name implies, a double has 2 times the precision of a float. In general, a double has 15 double decimal digits of precision, while float has 7, and so yeah. But we still don't understand what this means, right? So because sounds still cryptic a little bit. It is a precision, yes, and nice. What is it? And then you can see he shows here a code snippet. That's very nice. And the nice thing is you understand this a little bit till this point here. Probably you understand all, because we already discussed all what he is using here. That's nice. So we can understand code from other people on the net. This is very nice. And here he shows that the float value here has this precision when he uses this division here. He divides 1 by 81, then he loops here and assign this value, what he get to its this value b to its with a, also b plus a, and then next time again b, assign it back to b, and then b, and so on and so on. You see it, and then he get this precision, but he do this again with double, and you see he get here another precision. And when you compare now these two numbers, this one are almost equal, but they are not equal, and that is very important. For us most time not, for normal use cases not really, but later there are, for example, use cases where it will be very, very, very important. For example, think about it, they are trading here money, and one is using float and the other one is using double. Then the float one could be more happy. Let's say he get more money, so he can cause problems actually, because it's not precise enough. And the double one would be precise enough, so he would try to use a double, or there's another way, long double, or they would not even use float and double at all. They would just go to a rounding system which makes sure, which is clear what happens after a certain digit and something like that. But in our case, we try to understand only double, and you see it is just a precision problem. And in general, in our case, you can treat double as a float, but you must be aware when there is something like this example here. And interesting is, we can just copy this one too, copy, and use it in our code. So that's why many programmers are just copying that, and then I paste it here. Okay, I should copy it, of course. Copy it, then I go here to my code, and I test it if it's true. So now I saved it, now I run it, and now I see this, the top line is his number. Yes, it is 0. That's what he printed here out, indeed. And I could now run the other one too and see it will come out, this one. I showed you only this copy thing to show you that you can understand code in other websites. For example, Stack Overflow, you can use this code. So not only watch this code, I mean, you can just copy it to your IDE and test it on your own machine and change it to see what happens if you understand the code. And like I said, till all this here, what you see here, we discussed all. The only thing which we not discussed is this one. And here you can see he changed here the digit numbers, because normally we have 6 digits, and he changed here a little bit more the digits. And here in the second number, he changed even the digit numbers to 50, and that's why there are more digits which are printed out. Let me show you this one fast too. This digits one, you can just copy this one here, copy it, and so you can learn also to work with other on the web and to read their code, copy their code, understand their code, work with their code, and so on. And you can see now we have more digits, and even this both for loops, what you see here, are doing the same thing. The result is not the same, and that's the point about using float and double. And the last thing what I have to say is, if you don't put a f behind, for example, a decimal point number, it will treat it in C++ as a double. That's good. So you have all time this more precision. If you put a f for it and say this is definitely a float, then it will treat it as float with less precision. But it depends all on the use case and so on. In our case, we have just to know it, and it is very important when you later really work with, let's say, when you work with many divisions, right? Something like here in the example, he divided 1 by 81, and then you get this all decimal point numbers, and then he needed this one for any, I don't know, money, stock exchange, whatever, to calculate something with money, and every single precision is important there, because they are not very happy if they lose money. Okay, I think I talked here too much about that topic, which is very simple, but yes, you should research that. One more thing that's very important perhaps too. If you research this one, this precision, let me show you this one. For example, you go to Wikipedia and check this double precision floating point format, then you will see again a try of formal explanation. This is not a formal explanation, thanks God. This is more or less a normal explanation, but they use some formals here. For example, if you don't understand what they do sometimes in Wikipedia, the reason for that is most time you have not learned this college math, because most time they use just this college math, which you learn in the first year or in the second, depends, and a little bit formal but not too hard. And they learn here a little bit about technical terms which you learn in perhaps in informatics and in other areas as well. But in general, if you have a book which is written for normal people who try to learn a programming language, they will translate all these formal things here in a more readable way, in a more easy readable way, and then you understand it very easy. That's also very good to know. So get not shocked if you read sometimes Wikipedia and they start to use all these formal words, because most time these people who write, not all time, but most time this Wikipedia pages are copied from texts from universities or colleagues or whatever, and they just put it here in. And yeah, that's said. I think I talked again too much. We stop here. And there is one more thing which I have to talk in the next one. We have to train. We learned so much here again. But we have not trained it. We just get the information. Next, we start again a big exercise where we train all that. And yeah, that will be the best part of programming, I think, doing these exercises, because learning these keywords very easy, still take time, but doing the exercises there you prove and learn the most, I think, because like I all time said, you must be learning programming, and programming works only if you can use these keywords actual in a program with your creativity, with your own mind, and so on. But more about it in the next video. Bye.